Hey guys, we're back with another video, and today I'm going to be walking you through and how to wire a cooling fan with a thermal switch and a relay. In this video, I'm going to be breaking down all the details and what it takes to wire something like this and to wire it properly so it doesn't catch on fire. I'm also going to give you some tips in what parts you're going to need to complete the circuit, to make this circuit possible to be able to wire this fan. For our project Miata, we're going to be wiring this relay and this fuse, and it already comes together in this kit. I'll have a link in the description below if you wish to go this route. It makes it very easy, very clean to install. Just in case you don't want to spend the money and go get this kit, there is another option, and the option is to just piece it together. So you might have some spare relays, some spare fuse lines, and you could piece all of this together and make this circuit work properly. And I'm going to show you exactly how to do that in this video. I'm also going to install this very same kit on this vehicle, and I'm going to show you step by step how to do so. So let's get started. So in this side of the table, you can see we have a cooling fan, we have a relay, and we have a fuse, and we also have these two thermal switches. A little bit more on that later, but let's go ahead and look at in this side. And this is what I'm going to be building the circuit with. These are all spare parts from different vehicles, different projects that I have, and I'm just going to put it together to demonstrate to you guys that you don't need to go this route. You don't need to purchase this kit. You could just piece it together, and we're just going to get started right now. In order to make this circuit, you will need a relay, okay? You will need some type of inline fuse or any type of fuse that you have laying around. It has been connected to the wire. It makes it easier this way. You can put some spade connectors in between and go more of a DIY that way, but you're going to need these two basic components. So we have a relay and we have a fuse, inline fuse, okay? You're also going to need one of these thermal switches. These get connected into the coolant and or they get connected into the oil lines. And what they do is they take a reading of the temperature, and at a certain temperature, it turns on the circuit, it energizes the circuit, and at a certain temperature, it disconnects power. I actually have a very cool way in how to show you guys in how this thermal switch works, and I'll do that in just a second. These thermal switches usually have some type of engraving in the outside showing you at what temperature does it turn on and at what temperature it turns off. So we can see right here that this one's going to turn on at 190 degrees, and this is going to turn off at 175 degrees. Now, this is Fahrenheit, of course, it's not Celsius. And I have this other one here. This one's a little bit bigger. So this one will turn on at 185 and turn off at 175. So it turns off at the same temperature. It turns on a little bit quicker. It turns on 5 degrees quicker. Later, I'm going to show you a little demonstration on how this works. Let's go ahead and start wiring this circuit. All right, guys, so we're going to start right from the beginning, and we're going to start with the battery. The battery is what you're going to be transferring all that power to power this cooling fan, of course. And if we connect positive and negative to this battery, we could get this fan to work. So we're going to power up this fan with the battery. So there we go. It runs, it spins it, but it's not very useful. You don't want to wire it like this where it's running all the time. So we're going to start to build the circuit right now. All right, guys, so I put the battery in this side, and I went ahead and I attached the fuse. I have attached the inline fuse, and this part is the most important part of this whole circuit, I would have to say, and it's because it has the fuse. Always, 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 guys, try to connect the fuse as close to the battery as possible. Why would you want to do that? Well, because if this wire was to short itself where it would start to touch ground, you would want the fuse to blow before anything catches on fire, because if you connect positive and negative, it gets very hot and you could have a fire. You want this fuse to play a role in eliminating the circuit and preventing a fire. Very important, I emphasize, start with the fuse, put a fuse on there. Later, I'll go into a little bit more details in the correct size fuse, the correct amperage, but we have a fuse here. This is a 30 amp fuse. We're gonna get started with that. So again, just like before, I'm gonna connect positive, negative in this circuit, and we're gonna energize this fan, but now we have a fuse in line. And there it is, the fan is on. and then I would turn it off. So a lot of the times I see this happen in vehicles that I work on and in projects that I see abroad. A lot of the times guys like to wire the switch in this type of arrangement. So they will have the positive going straight to the fan, the ground going into the switch, or vice versa. You could have the power going to here, and they just toggle on the fan, just like this. Okay? And you could turn on the fan. I would have to say only in an emergency or an emergency repair you should do this. The reason being is because these switches, they're not rated to withstand the amount of amperage it's going to take to run this fan. You might be able to find a switch that has a higher rating amperage, and you could do this, but you're going to have to run a thick fat wire wherever the switch is located inside the vehicle, inside the glove box, inside wherever you're going to be toggling it on, and it's not ideal. You will want a relay in between this. And that's what we're getting ready to wire in. We're going to wire an electro switch that's activated through this switch, but the relay does the heavy lifting. The relay transfers the higher amperage into the fan. And let's go ahead and wire that and show you how that works. Okay guys, so this is the relay I'm going to be using, and that's simply because the spade connectors that I have, they plug into here a lot better, and it's going to be easier for me to wire up. But you could use this type of relay as well, even though it is a little bit difficult to wire up. So basically what I'm using here is I'm using this relay to show you, because you can see the wiring diagram a little bit better than this one. This one's engraved, and this one actually has some printing on it. So right now what we're going to be wiring is the circuit 87 and 30, and that's basically this switch. We have just wired, we're going to wire the toggle switch. You can see this is an open circuit here, and when it gets electrified, and I'll show you exactly how that works in a second, when it gets energized, this circuit will close, transferring the power to turn on the fan. So basically it'll turn on just like this, but remotely. So just like I said before, I'm going to wire the 87 and the 30. And how do I know where they're at? Well, usually, most of the time, right underneath the relay, right where the prongs are, these little connectors, you can see the numbers. And I could see there's number 30 and there's number 87 right here. So now I have wired up the relay so it could do this function, the switch function, okay? But you can see the fan hasn't turned on, and that's because we need 2 more components to be able to do this. So now that we have 30 and 87 connected together, we're gonna wire 85 and 86 together. And now these, sometimes they are polarity sensitive, meaning that only positive could come in one direction and negative in the other. Sometimes they are sensitive like that, and sometimes they're not. So we're gonna go ahead and wire this one up. Depending on what model relay or type of relay you have, it might be sensitive to that. So keep that in mind when you're using this relay. You might have to wire up the 86 to negative, or you might have to wire the 85 to negative, depending on the model relay you have. Sometimes they are sensitive to polarity, and sometimes they're not. In this situation, this relay doesn't really matter. So let's go ahead and do that. So now I'm gonna go ahead and wire this up, and I'm just gonna put these wires here. And notice that these are just speaker wires. I'm just doing a demonstration here, guys. And I'm gonna grab one of these wires, and I'm gonna connect it to one end and connect it here. And now I will energize the fan, the relay, and everything together. So once again, gonna energize it, and it turns on. Now, what is going on here? Let me explain, let me break it down a little bit. Like I said before, I do have a video in how a relay works. We're not gonna get too into it right now. Basically, these 2 wires that are right here, okay, they are controlling an electromagnet. That electromagnet pushes down the contact on circuit 30 and 87 and lets that power get transferred over. So now when I energize that electromagnet, this electro switch, this relay, turns on, transfers the power over, like this. So now I have wired the switch into the relay. And this is the proper way in how you would wire this. You would wire the relay connecting the high amperage to the fan, and you have the switch, this switch activating the electro switch, just like this, and the fan will turn on, just like that. And you could toggle it off. We don't want this switch here. We want this to work automatically. We want this to work with the thermal switch. So when the temperature reaches the correct temperature, the fan will turn on. So now we're going to eliminate this part of the circuit. This part of the circuit that turns on the fan, it's going to be eliminated now. And pay attention to this part, guys. I have the switch wired to the ground, and that's what the thermal switch is going to be providing in the circuit. It's going to be providing ground. So we're going to turn this on once again. So I'm going to grab this microphone and I'm going to put it as close as I can to this relay so you could hear it turn on. I'm going to put it right here, and you're going to hear a click. This is an audible click. That click that you were listening to is the electro switch activating, transferring the power over, okay? So now we're gonna go ahead and wire the thermal switch in. So the really cool thing about this thermal switch is it's automatic, it shuts on and off at the right temperature, and it provides the circuit with a ground. And how does it do that? Well, let me explain a little bit. So you can see that this thermal switch has some threads, and this will tie into your engine block somewhere or some type of metal housing that you have. And when you thread it in, your engine block is grounded. It has ground already. So it would have the ground from here, and this part right here, it's insulated. This connector is insulated. And at the right temperature, it would let you transfer over the ground from here over to this spade connector. And let me show you a little bit how that works. Right now I have this alligator clip hooked up to the spade connector, and I'm gonna touch right here where the threads are. And you can see the fan did not turn on. There's nothing happening. We have to heat this up to get this to energize. We're gonna do exactly that. Okay, so I'm gonna use this heat gun to heat up this thermal switch, and we're gonna activate this relay. The thermal switch is gonna activate, it's gonna activate the relay, turning on the fan, completing the circuit. This is how it's gonna be wired in the vehicle. Gonna go ahead and turn this on. All right, so it turned on, it's on right now, and I'm gonna go ahead and turn and disconnect this switch to prove to you guys. So now it is hot enough that when I connect it back, the fan turns on. Now we're gonna cool it back down, and we're gonna see the fan turn off. So now I have some ice, and I'm gonna cool this thing down. And the fan should turn off briefly. And that's it. So now it has cooled down enough where there is no longer a circuit. You can see it has shut off. And that's the basics and how this works. I'm gonna demonstrate another test, and I'm gonna show you guys the fundamentals in how this thermal switch works. So if my camera person could move a little closer. Right now, right in front of me, I have my scan tool. It's also a scope and a digital meter, and it's very fancy. So the reason why I brought this out, it's because with this scan tool, I am able to give you guys a better visual of what's going on. Right here, I have these two terminals, and I have the settings turned into ohms. So ohms is basically continuity and how much resistance is in a circuit or a device or a component when it sends a voltage from one side to the other. So it measures the resistance of a circuit. So we're gonna touch these two wires right here, and they already have been calibrated. We're gonna touch these two alligator clips, and you can see it has zeroed out. It has 0 ohms, which means the circuit is complete. These wires are in good shape, and it's time to conduct this test right now. So I'm gonna go ahead and disconnect them, and I'm gonna connect one side here where this is grounded to the vehicle, and the other one to the spade connect. And you can see there is nothing showing up in the screen. If I was to touch this connector here, it has detected that there is some type of continuity. So we're gonna connect it back to this side, and there is nothing happening. And that's because the thermal switch is not activated. Remember, we need to apply heat for this to work. So we're gonna go ahead and apply some more heat on this one. So I decided to show you guys and demonstrate with the other thermal switch to show you that it basically works the same way. I'm gonna turn this on. And once it starts to heat up, you will see something light up here, there will be a signal of some sort. Depending on how good these alligator clips are clipped on, it would either go to 0 or give us a value. Right now, it's showing us that there's an open circuit. There's nothing there. So there we go. We're getting something. We're getting a reading. And like I said, it was either going to go to 0 or it was going to show some numbers. And it has turned off because it got cooled enough. Let's go ahead and heat it up again. Okay, so once again, I'm going to cool it down with some ice. And we're going to see this disappear in a couple of seconds. And you would see nothing in here, meaning that the circuit has been deactivated. The switch has turned off. And there we go. So now there is no continuity running from this side of the circuit to this side. It is completely insulated. So you can see the multimeter is showing there's nothing connected. And once again, if I was to connect these two wires together, you can see that there's continuity and you can see the multimeter is working. So pretty cool. Hopefully you have a great idea right now in how all of this works and how you would wire it together. I will have a very basic schematic pull up on the screen so you guys could use this video as a reference and you could have a schematic at the same time. And I will have a link in the description in this whole wiring harness, because this whole thing that comes together and it looks beautiful is what we have created here. Now, if you was creating this at home, you would use different wires. You wouldn't use alligator clips. But now that I have demonstrated in how this works, I'm gonna wire this in real life in this vehicle, and I'm gonna connect this cooling fan to the oil cooler, because that is why I purchased this thermal switch. This thermal switch is gonna be trying to activate when the oil reaches 195 degrees and turning off when it goes below 175 degrees. So there's a lot of benefits to this. I don't have to turn it on and off manually. And also when I start the vehicle in the morning or a cold start, the oil is able to warm up to the proper temperature. If this circuit was wired manually or it turns on as soon as the ignition is on, it could prevent the oil from warming up quick enough, or the fan will run all the time, which is, who wants that? I don't want that. Nobody wants that. So that's basically what we're doing here. We want a thermal switch regulating when the fan turns on and off. I'm gonna go ahead and wire this up and show you guys the finished product. Okay guys, I have wired everything up. So the fan is currently wired up, and right here you can see this is the power wire to the fan. This is the ground wire to the fan. You can see I have grounded it right there. So there's power coming in and there's ground. Also, way up here is where I connected. Let's see if I could remove this. You can see, I guess I can't. Right here, I connected to the power. This is where I'm receiving the power to the relay, and here's the fuse. You always want to put that fuse as close as you can to the power source, just in case you short out. This fuse will blow from here. I have the danger of it shorting out right here and not having a fuse, so I am going to insulate this very well. Gonna seal that up in a little bit, and you can see right here the wire from the fuse goes into this relay. This is the relay that we were talking about. Okay, so we have positive and negative on one side, and the signal wire from the thermal sensor is right here. I disconnected it because, well, I can't show you. It sits tucked inside there, in between the sandwich plate. So the thermal switch is installed. Here's the cable, and remember, the thermal switch provides the ground to the circuit. So there's ground coming in to this engine, this whole block. The engine is grounded. So right now, what I'm gonna do is I'm gonna turn the ignition on, and I'm gonna show you, demonstrate without the ignition on. Right now, I know this is a good ground. I already tested it. I'm gonna ground it here. No fan turned on, okay? So basically what I'm doing is, instead of using the thermal switch, I'm activating it right here
with this wire. This wire will provide the signal to turn everything on. The thermal switch says, hey, it's hot enough, it turns on, but right now we're getting nothing. So I'm gonna turn the power on. So now we have ignition on, and I just finished installing all those gauges. If you wanna see this build, you can check it out. I'm getting ready to post a video on this. So all these gauges have currently been installed, and I ran the wire right in through here. You can see some of the wires are grounded here and some of it goes inside there. Now let's go back to the fan. So now I'm going to ground this wire, and you're gonna see and you're gonna hear the fan turn on. So I'm gonna put it right here so you could see it and you could hear it. And there it is. And you can see I'm grounding it. And then I disconnected. Now, this is what I was saying, that this block, this whole engine has a ground. Now, remember, when that thermal switch gets hot enough, it closes the circuit and all of a sudden it turns on. When it cools off, it turns off. Here it goes. Let's say it got hot enough. You can hear the fan, and then you disconnect it. So you could also hear the audible click on the relay right here. This is the relay clicking on and off. It's a very simple circuit. It's not complicated at all. As long as you follow the steps that I showed you, you should be just fine. Now, when it comes time to choosing the correct fuse, this is a trick that you could use. Majority of the time, you are gonna have a label where it's gonna tell you how many watts, how many volts, or amperage. Right now, we're trying to figure out how many amps. So what you could do is you divide the watts divided by the volt. So basically, you get your calculator out and you can estimate how much amperage you're gonna need. Now, sometimes I have discovered that sometimes these run a little bit below what the reading says, okay? And sometimes when they get really hot, they go a little bit above. So we're gonna calculate this, and then we're gonna put an amp clamp on it and see how much is it really pulling. So here we go, I got my calculator out. You can see I'm just gonna go 80, okay? And we're gonna divide it by 12. Yes, you could divide it by 12 because it's a 12 volt circuit, but technically, really, when you are running with the alternator on, this is going to be 14 volts or 13.7. We're going to estimate a 13. I'm going to run 13. So you have the equivalent of around 6 amps. So we know that to run this circuit, it's going to take about 6 amps, okay? 6, 7 amps, 5 amps to run this circuit. I technically don't have a 6 amp fuse. I went with a 10 amp fuse. Now, I would never tell you to go too high up. We only need 6 amps to run the circuit. If I was to go, let's say 20 amps or 30 amps, and this wire right here is not rated properly to run that much of a amperage, if there was a short to ground from the power, this fuse would never blow and the wire would catch on fire. And I have seen this happen, and it's not a pretty sight. Make sure you guys are using the proper gauge wire and the proper amp fuse whenever you're doing this, okay? So right now I decided to put the battery on the charger, and that's because the ignition is on. We're gonna be running this fan. I wanna get as close as possible to the correct reading that fan's gonna be working at. So if I was to just drain the battery and run this test, then it won't give me a good reading. So I want it up there at right around 13 or 14 volts. Let's see where we're at here. So you can see it's at 12.9, and we'll leave it on the charger and just do this test. Okay, so I grabbed my amp meter, and basically what this allows you to do is measure the amount of amperage going through a piece of wire. So you would open this up, you would put the wire inside the center here, and it reads the amount of magnetic flux that goes through this clamp, and it's able to give you a pretty good reading on this. So you can see right now it's an alternating current. We're going to switch it to direct current. So it's currently now in direct current, and we're going to zero this guy in. You can see there's a little bit of digital rattle, I guess that's what they will call it, and it has been zeroed in. So we'll do it again once I clamp this on,
and I'm putting it around the positive wire here. So I have it here, and I'm gonna try to zero this in and get it as close as possible to 0. You see I have it in 0. And now I'm gonna just leave this here because I have to record with the other hand. So I'm gonna ground this wire, completing the circuit. Let's see if we could get a better ground right here. Okay, I have completed the circuit and the fan is running. And you can see we have about 4 amps. Let's see if we can move this around. It started at 3, went up to 4, and the fan is running. Remember, we calculated 6. So more than likely, once it starts to warm up, and I have done tests where the amps start to creep up. So it's operating pretty comfortably right now at 4 amps, okay? And just like that, the fan has turned off.
Okay, so now that I have confirmed that this is going to be running below, it looks like it was running below. It might go a little bit higher, but it's going to be right around 6 amps. I think I'm going to go with a 7.5 amp fuse. If it blows it, then I know I'll go back to the 10. But we're going to start with this and see how it performs. And I'll do some fine tuning later. I don't want to go too low where it blows it all the time, but I don't want to go too high either. Because if there's something wrong in the circuit, I want this fuse to be tripped easily.